Hello, we're starting the next part of our rendering, and this part involves passing render data to the GPU. Up until now, we've been rendering a triangle by hard-coding some values in the shaders, but this is never going to be a production case. In production, you will always pass data to the GPU. This is usually done by passing what is called a vertex buffer. The vertex buffer is a list of data structs which contain values, like color and position of the triangle corners. I'll start by adding a new region here to actually encapsulate all the class methods. We will not work with them so much from now on, and I collapse that region so that I have a new region here called buffers. We need to move out these shader values from the vertex shader. We will preserve the out and in values to the fragment shader though. We just don't want them hard-coded in here. So let's delete them now. In the shader, we can now describe what we expect to be provided by the app. We add two in parameters for position and color, and they will be bound to the layout location 0 and layout location 1. And we can now use those values down here in the main function of the shader. If we use a vec3 color without transparency, we have to make a vec4 out of this. Now I will create a new file called vertex.h. Inside, I add a pragma once and the namespace for our Vulkan engine. We will create a new struct to match the data that we'll be passing to the vertex shader. I call it vertex and I add two vector3 fields for position and color. The ordering here doesn't really matter, but it's best to match the shader locations. Now, when we create the graphics pipeline, which is responsible for the shaders, we will also have to specify how these values are structured. So let's create a new static method here. It will return what is called a vertex input binding description. And I will call it get binding description. I quickly add the header to the graphics file here. We will use it later. And I also include the Vulkan header file to fix the errors with the unknown types. Inside the static function, we will create a new binding description. The vertex input will bind to 0, and it will have a stride equal to the size of the vertex struct. It will also have an input rate of vertex. You can also render multiple instances with the same vertices, but we will not explore that. We also need one more method which will return an attribute description. I call it getAttributeDescription, and we can create this description object and return it. And remember to add the return statement to the previous method as well. And actually I made a small mistake here. The attribute description is actually two descriptions. The attributes are each of the vertex fields for position and color. So having made this into an array, we can now set the descriptions. Here I set the binding of the first, and we also need to set the location. And this matches the location in the shader file. After that, we can set the format, and this format doesn't actually reflect what the field is used for. So even though we set a position, we have the format of RGB floats with 32-bit size each. Finally, we set the offset in bytes where the field can be read. The best way to not make a mistake is to set it to the offset of the field. I copy this section for the color and I change it to the correct location and offset. Now, if you go to the graphics pipeline, we can set the descriptions to the vertex input creation info. I scroll down until I find it, and here I can call the static methods. I get the vertex binding description and the vertex attribute descriptions. And I will also refactor this method to reflect that it is a multiple. In the vertex input info object, we can now set the vertex binding description count to 1, and then set the others to the vertex binding description. And we can also set the attribute description count to, then set the attribute descriptions. And we actually having an array here, so we can set both fields to the size and the data of the array. And let's correct the field here since I auto-completed the wrong one. This is it for describing the vertex. In the next lesson, we will create the buffers in memory and ask Vulkan to render them.